before we start here today, I have no idea how long this is going to take. This could take forever. Like, I could stand here for hours, and you would have to sort of throw me out. So let's just take it as it goes. There are multiple levels of jokes in the title. I have a very, very bad sense of humor, so it might not really shine through. But that was the intent behind the title. All right. Should we start? Everybody feel like we should start? Let's get the ball rolling. Awesome. All right. First question. What is a Scala concurrent future? What is it? Any ideas, suggestions? It's a box. All right, fair enough. There's something highlighted on the screen. Has something to do with concurrency, right? Or hopefully. Naming is hard, but hopefully, right? So I hear quite a bit. So one section of this talk is about what's coming in the future, right? But this section of the talk is about the current future, right? What are we working with here? And I think there's a bit of confusion. So what's a concurrent future? Because why isn't it a task? What's the concurrent part? Well, the concurrent part is that has to do with coordination of some sort, right? Trying to coordinate between different concurrent things, perhaps. Make sense? Useful? Passing things around between logical threads of control execution, right? It does have to do with concurrency. So let's keep that in mind. So technically, you could view it as something that is initially unknown, for some definition of initially, and then some value or some exception. So there's an arrow there. It doesn't go back from that. Once it becomes a value or an exception, it doesn't go back to being sort of undefined or unknown. So in types, it would sort of be like an eventually of tri of t, right? And eventually is not an actual thing, but it's eventually a tri, which is a data structure that represents a value of type t or an exception. Everybody feel like this is comfortable? Uncomfortable? Horrible. All right, okay, so we're cool. More technically, it's an awaitable of t. Why is that important? Anybody? Anybody fast? You can block? Sorry? Get a value out of it? Yeah, so the value is the t, and you can block on it. And why does it make sense to encode this in a type? Why would you want to do that? Do you want to do that? Why do I want to do that? Sorry? Yeah, so I can keep on going, but also because it's a separate concern, right? Wouldn't necessarily have to support blocking. And if it is its own type, it could have its own API. And we could know what's blocking and what isn't blocking, right? All right. So let's have some history. So one of the first futures, take the Java util concurrent future, has a very sort of blocking API. Getting stuff out within a certain time or blocking indefinitely to get something out. But there are more APIs. So is completed, right? Polling, is it done yet? I don't want to block, I just want to know if it's done, and if it's done, I'm going to pull something out. So that's one API, a polling API. But there are more APIs. A callback API. So on success or on complete or on failure, Will you supply some sort of callback? That's one API. But I think in the end, we've arrived at really sort of pushing the transformational API. Sort of taking something that will be available at some point and transforming it once that happens and producing something new. Why is this important? Why is this sort of progression important? Because we don't stop just because we found a solution. We continue until we find a better solution. Right? Some use cases do not support transformation. Some use cases only support polling, for instance. So there's still value in providing multiple APIs. It's just a question of how do we promote certain APIs in certain situations and other APIs in other situations. And how do you communicate with users, and how do users internalize when APIs are appropriate to use and which APIs they should be using. And I think today what I want to tell you is that if you have the choice of using the transformational API, you should use the transformational API. I'm going to try to sort of enunciate why that is the case. So, async versus synchronous. What happens where and when? So one common criticism against the current Scala concurrent future implementation is that it needs to have this execution context. Right? Why do I need to have this execution context, and why can't I just add my stuff and stuff just happens? Why can't I have good things? Yes? Like a pool lock? Pool lock? Starvation? It's a good comment there. Good comment there. Threads aren't cheap. Exactly. Also, let's say that you were to add a transformation to be executed once the future has been completed. What thread would actually run that? So, in the case of the completing thread invokes this transformation, what happens if that is an expensive transformation? What happens if that transformation triggers more transformations? What happens if that happens in a sort of infinite sequence, where the thread needs to call the next callback, to call the next callback, to call the next callback? When does that thread get back to doing what it was supposed to do? Also, there is a race condition involved here, right? So what if we add the transformation after it's been completed? Then we run the callback. So now we have a built-in race condition into our program. I think that's a bad idea. So how about we pick something and we just make sure that that's what happens. Like we like determinism in the sense that it helps us reason about our code. So if we know that this thing will always be invoked in an asynchronous manner, seems like a better trade-off than it's always executed synchronously, right? Because we wouldn't know what would execute it synchronously. Which thread? The completing thread or the thread that adds the callback? Right? So this is why being able to say this runs on this execution context makes sense. Because if you have a piece of logic that produces values for futures, you might want to isolate that logically from the rest of your program, saying that this thing is run on this thread pool and this other thing here is running on this other thread pool. And I don't want them to interfere with each other. All right. So since we have this concurrent future, what do we need when we do concurrent programming? We need relationships, right? How do we know how things happen? So this is an important guarantee. The completion of a promise happens before, which is a very well-established terms in terms of memory visibility, the invocation of the callback. We know that if we publish something into this promise, it will be safely published to all the consumers of its future. Important, super important. This is not super well stated in the current documentation, so I think this is an important slide. All right, so going back to the execution context. Something clicked for me when I realized that it's about an interpreter. You're essentially saying that this logic should be executed by this interpreter. So if you think about execution context as an interpreter, to me, it might not be to you, but it's a suggestion. It makes sense. I'm adding an interpreter for this program that gets run on this completion of this future. All right. So let's just try a demo here. And this is live coding, people. I mean, everything can happen here, probably will. Let's just roll with it. All right, so let's say that execution context is an interpreter, right? If we wanted to create our own interpreter implementation here, we extend a nice concurrent link queue, because we need to add things concurrently. That would be nice. Just use the Java thing. It's well tested. And for each of the things that we should interpret, we add it to our queue ourselves here. So we're just appending things to our own queue. Everybody with me? If somebody's like, dude, that's crazy, just tell me, and we'll sort it out. And while this may not be super important, one of the important things that I think was in the execution context definition was the ability to log errors where there weren't any apparent receiver of an error. So let's say that you have a completion callback and that fails for some reason. Who would know? Right? If a tree falls in the forest and nobody's there, did it happen? With this API, it can actually scream into the internets and everybody knew that the tree fell, right? All right, so let's say that we now have an interpreter that just stores things to interpret. And mind you, runnable might not be the most elaborate of algebras to interpret. Might actually be one of the smallest, because it's essentially like a function from unit to unit. But at least it's something. And let us define a method that allows us to interpret the next thing to interpret and return a Boolean whether there are more things to interpret after this. So we're polling our queue, and since poll can return a null, we wrap it in an option. We use options fold to return false if it was empty. And if there was something called R, which is our runnable, we print it out, because that makes sense. We run it, and we return whether we were empty or not. So if there's more information. That makes sense, everybody with me? We can interpret runnables. Awesome. All right. So let us say that we have this program, which has the manual execution context, and we create a future of a list of make foo, not bar, right? And we want to create a string out of that because that's a very sensible thing to do concurrently, right? Don't want to do that in your own thread. Let someone else do it. This won't really do anything, right, until we interpret the code, right? So if we don't interpret anything, this test should fail, right? Are we cool with that? All right. Let's try it out. Let's see what happens. All right. So it fails, right? So we didn't interpret what was supposed to be interpreted. and we were waiting for the result, but it never showed up, or within our timeout. So let's try to fix the program, right? We interpret the single thing that we should interpret, and hopefully this time it will actually pass. So we've created our own execution context. We've decided when we wanted to interpret things, right? Simple enough? All right. So let's say we get really adventurous and we want to map identity. Because this is one of the most useful transformations I found, because it doesn't destroy any information. What should happen? It fails? Doesn't fail. Doesn't fail? Fail. Fails. All right, let's see what happens. So it fails. Right? Because we added something more to interpret and we didn't interpret that thing. So let's say that we want to fix this problem. We do. Right? Passes. Right? Short circuit, we don't interpret unless there's anything to run, and we only interpret again if there was anything else to do. All right. Let's get back to this one. So have I sold you the idea of execution context being a sort of an interpreter? No? Not really. Oh man. This is going to take forever. All right. So what's new? Well, for 2.12, on success and on failure is deprecated. Why? Right? Why? Well, turns out that on success is just a partial version of for each. It takes a partial function, right? And on failure is just a partial version of failed.forEach. Right? So why have multiple ways of doing the same thing? When would you decide to use whichever of them? So that's why they're deprecated. All right. So one annoying thing that I found, and if I read Stack Overflow correctly, others have found this as well, having to flatten futures using flat map identity is not necessarily the most ergonomic way of doing it. Why is that the case? Ideas, suggestions, hate mail, screams of insanity. Nothing? Doing it all the time is... Well, if you end up doing it a lot, one sort of dirty secret is that identity is a method. It's not a function. So whenever you do this, you're allocating an identity function literal out of the identity method. So you're essentially creating a new identity function needlessly because it's a very trivial operation. But also, it requires an execution context, right? You could put any code in that F. You could, like, system exit or something. So we can't really optimize anything. So flatten is new, right? It feels fresh. Doesn't require any execution context because we can prove that we're just unnesting a future. So it's not an expensive or weird operation that would necessarily need to live somewhere else. We can just flatten the future. So it saves some typing, right? But also, it saves us from allocating things needlessly. All right. So one thing, when you want to combine two futures and take the results of both and do a transformation, you either need to do this sort of flat map dance, or what I call the SIP map that crap. You SIP them first and then you map over them and then you create your result. Why is this necessary, really? I mean, it should be some sort of like core thing to want to be able to combine two things and transform their results, right? So how about sit with, right? Take some future, sit it with some other future, and supply it with a function to transform the values. No need to create the intermediate tuple. No need to do this sort of two-step async dance. Seems nice, right? Looks good. Should be nice. And also, as we can see, that SIP is actually a special case of SIP with tuple2.apply. Cool. All right. So this is one of the most exciting news of the 212 futures. So all you future aficionados that have read the Scala Future documentation over and over and over again, you might know that there is already a method called transform before, right? But that transform is more clunky. It takes like a function from the result type and then sort of like a by map, sort of transforming an exception case and transforming a success case. This version of transform is strictly more advanced. So what is the thing below the definition? It's code, right? That's map. Yeah, that's map. Transform the try by mapping it using a future. So try has a map function. So this is the definition of the map operation on future. Turns out that there is another interesting function called transform with that is new. Right? What's this? What are these two seemingly weird things beneath the definition or the declaration of the method? Any takers? In the spirit of the previous answer, it's flat map. The first one is flat map. What is the second? Takes a failure case, applies a partial function, recover with even. Awesome, right? So we have this more powerful operation that we can encode these other operations with. That's pretty cool. So it seemed that there was something strictly more powerful that was just hiding just behind flat map and recover with. All right. So let's try another demo. I'm not sure we have time, but I said this was going to take forever, and you agreed, so. Let's see here. All right. So one common criticism is that it's impossible to compose behaviors for futures without requiring an execution context. Have you heard this before? Have you experienced it before? Have you sort of silently hated me for that? Have you verbally hated me for that? Right? This is a common thing, right? Why do I need to require an execution context to do the most basic of things? Well, I'm saying that from 212 and forward, you don't strictly necessarily need to have that problem. Because if we have a method that takes a function from try to try, and a function that takes a try to a future, then we can compose those. So let's say that we have something we call parse int, takes a try, tries to parse an int from that thing if that's successful. And if we have a try of int, and we want to apply to a hex string, we could do that. We can compose, I mean, this is function composition. Sounds amazing, right? Sounds like something that could be very useful in a functional language, right? So if we can compose these two things, we have a new function. So we have now composed a behavior for our thing, and we haven't seen the need for an execution context yet, right? So if we then complete our promise of a string with this amazing number, and then supply our transformation to transform, we give it some execution context to perform this transformation, right? We give it the interpreter when we need to. We should get a cafe out of that, right? I think so. You don't seem super convinced, right? But we do. We could create a transformation in itself, compose it, and supply it to a future when we need it to, right? So not strictly necessarily having to pass around an execution context at all points in time. You don't seem super convinced here. What's the difference? So how would you compose these things? So if you were to use map for it and just use normal functions from t to r, right, instead of trie of t to trie of r, you couldn't necessarily do the recover case, you couldn't necessarily deal with those things. So this is strictly more powerful, but you could do something similar, but you couldn't really deal with the failures. You would have to resort to your own sort of try-catch stuff. All right, back to the talk. All right, this is huge, right? We have a future in 2.12 called unit. I mean, right? We have that now. So one of the biggest news. And to be fair, it's only a future that holds the value unit. But it's amazing how often you need that. I've seen it so many times where somebody creates a new future successful of unit, not even funny. So having a dedicated unit for this is pretty nice. Why is this nice? Well, you might ask yourself, did Viktor just really pull off a bacon lambda? Well, I think it did. Right? If you think about it, the apply method on future to create a future out of an expression is just syntactic bacon for future.unit.map, right? And it's actually implemented like that. There's no difference. All right, so going with the theme, there's a future never. It's a very grim future, for sure. So what is the problem with the code above? Or what is a problem with the code above? What is the good thing about the code above? Before? Happens before? Not an issue. But what happens if you want to represent a future that never completes and you pass that around in your program and somebody adds a gazillion callbacks to that? What happens? Well, you have a memory leak. Because it will gladly sit around there because it can never be completed because there is no value of nothing. Right? There's no value of nothing. That's pretty deep. But there is a solution for that now. So you can actually pass around future never in the case you want to represent that. And that will not leak memory. All right. So one thing that really got me hooked to futures was a programming style. I think it was Marius Eriksson at Twitter that I saw doing this the first time. And I call it async continuation passing style. I don't know what he calls it, but he's probably right. You have to call it ACPS now, for now. And while the code here might look unnecessarily contrived, let's imagine that we wanted to abstract over mapping over a sequence or an iterable over something and only continue with the next transformation once the previous one completes. So we want to do it step by step but asynchronously, creating a new iterable out of that. So what happens here is, if you look at the last line first, we're creating an iterator over the passed-in iterable, and we're using the amazing can build from API that has been very highly esteemed for a long time to create the initial builder for this. We want to build the next collection out of this. And once we have an iterator, oh man, shouldn't have done that. If we have something in it, there's more values, we create a future that in itself calls f, applies the next thing, returns that as a future, right? So we have the value of the application of f to the next thing in the iterator. Are you with me? We have transformed one element right now using f, and using flat map, we recurse. Right? We do flat map, we have the builder, right? We apply the next step. So we're essentially doing async recursion. And since we're calling next, once I no longer has next, it will return a future that has the successful value of the result of the builder. That is the termination point. We have now transformed all the things in this iterable, and here's the new collection. Does this make sense? So the ACPS part of this is using flat map or recover with to essentially recurse. Super powerful pattern once you get to use it. So there's one problem that gets exposed by this kind of pattern, and the solution is called root compression. Because if you have this sort of, if you look at the recursive calling, right? So you return a future immediately, right? That's the point of the future construct, to be able to return it immediately and doing the transformation asynchronously in the background. It means that the first future that was returned will be completed last, right? After all the things are done, that's when it gets completed. So it creates this sort of chain of futures that don't have any value until the end, and then you sort of unwind the proverbial stack until it has the final result. Now there is an optimization technique called root compression that eliminates the intermediate results. So when you complete the last future, you complete the primordial future immediately, not going through all these other futures. So that can save a lot of memory leaks. And what's new in 2.12 is that since we have this transform with combinator, we can apply the root transformation for that specific thing. So no matter if you mix flat map or recover with using this sort of async continuation passing style, you'll get the root compression built in. So you don't have to worry about that. Make sense? Sort of? Ish? Not at all? Hello? Yes? So it's sort of like stream fusion. It's more like, stream fusion is more collapsing the processing. This is more collapsing the result creation. So it's similar in spirit, but not necessarily in execution. Some of the nonsense stuff that I did find was there was no protection against trying to complete a promise with itself. So that has been sort of quietly fixed, because that doesn't make sense at all. And something that I think doesn't get the necessary praise / attention that it might or probably should, is the block context. And I don't know if you've ever seen this. It's there, but you don't really necessarily see it unless you go looking for it. So the block context is a means of letting the underlying thread pool know that, all right, we're going to attempt to do some blocking here. And that is useful for many reasons. One is debugging. If I can install a block context that will print out before it tries to do any blocking, it's much easier to find out whether some blocking was involved or not. And this only works if you actually use the block context and the blocking construct here in the sub method which uses blocking does the demarcation of the blocking section. So you can wrap whatever blocking thing that you do in a blocking block. A lot of blocking. I don't necessarily like blocking, so this is painful. So let's try and see what we can do with block context. I have no idea if I'm running out of time or not, but you're sitting here and you're not screaming, so let's roll with it. So let's say that we want to create our own block context. It has this really peculiar looking method, which is its only method, that's called block on, that takes a type parameter t and a thunk, right? A thunk that evaluates to t, and it has this implicit permission to be able to await. And this is important because it prevents code from calling this method directly, because you have to supply this sort of proof that you're allowed to block. It's sort of adult supervision kind of thing. But let's say that we wanted to install a block context that prevents blocking. Right? So we create this future that will produce the fantastic string pigdog, and we would like to wait for that future to be done for waiting 10 seconds, and we have this sort of implicit global execution context. So imagine that this piece of code is any library code or any other person's code or perhaps your code from 6 months ago. It doesn't really matter. What matters is that this doesn't necessarily deal with any of the block context stuff, right? The only thing we see here is await result, which is a very good API because it means that it's easy to disallow. So if we wanted to install the block context that does not allow blocking, right? So we install this here. Oh, this really does not wrap around well. Right? We install this block context around the invocation to some API call, right? And if things work well, it should produce this illegal state exception, right? Are we okay with this? So what should happen here? Right? What should happen here? Where is my block context? All right. So we don't allow blocking anymore. We throw an exception before the code that does blocking. So this allows us to do some very interesting things. Like the global execution context tries to compensate by creating more threads. So before you do the blocking, let me create a new thread so that the thread pool will remain alive or responsive while you're doing this blocking. Or you might want to do some logging, or you might just want to prevent people from doing blocking. The possibilities are infinite, sort of. All right, so some things that most people are not aware of. The global execution context is actually configurable from the command line. So there's this notion of minimum number of threads, which is sort of the ideal number, a max number of threads, and a max number of extra threads. And the extra threads are the threads that will sort of prevent the thread pool from starving if there is blocking. So that's the max number of extra threads to keep the thread pool alive in case of blocking. And for 212, the threads actually have sensible names. That's pretty cool. All right. So, given that 212 is for Java 8, you may want to consider using fork join pool's common pool, because that's already there. It's already being used, and sort of, mind you that when execution context global was created, we actually had our own sort of private fork of fork join, because there was no common pool at all. One mistake that I very regularly see is that you create your own execution context rather than requiring from your caller. Really require it from your caller. Because if you write your program quote-unquote correctly, the only place in your code where you will have to specify an execution context is when you actually start your program, because that will then be passed down to all the places where it's needed. So please do that, because otherwise there becomes like this proliferation of thread pools, and it's really hard to figure out what's executing what and when. So if you have your own execution context, really have a good reason for having your own. Like, I want to isolate this piece of my system from this other piece of my system. That's a good reason. But don't sort of create your own just for the sake of doing it. Remember, think first. I see this all the time, and especially with concurrent and asynchronous programs, it's well worth investing in thinking about the problem before you encode the solution. Because it's so much harder to debug concurrent code that was just sort of put together in a rush than to deal with something that was really thought out before. So you won't really necessarily be able to solve your problem by just throwing code together. So really, for me, Scala was a lot about having to think before you code. And I think this is a really good thing. And don't worry about not having written any line of code yet, and it's been an hour. Because if you've thought about it, you might actually not create lines of code that will create a problem with someone else or yourself. And I pulled off a bacon V too. This is one of my better images that I've made. I think this is historic. So do you guys have any questions? Or do you feel like you have like a future overload? You're completely mind blown. Or bored out of your minds. Yeah. Yes, that's a really good comment. So when you do a lot of work, it doesn't really necessarily just have to do with doing future composition or function composition, but when you do a lot of work in one transformation, you're essentially hogging a thread until you're done. That's the trade-off between fairness by doing a lot of small stuff and letting other things run interleaved, or being efficient and hopefully getting better throughput by doing things while you're doing it, right? I might just as well do more because I already have a CPU and doing stuff. But that's a good comment. And I think it's the same recommendation as with any code. Like, try to keep logic to a good sort of boundary or a sensible. I think it's hard, right? It's about taste. Like having sensibly sized methods and functions and not really doing too much. But at least that's easier to profile because you know what's running. You can inspect what's running. But yeah, it is a trade-off between sort of fairness and throughput. Cool. All right.
For myself or other people, where would you suggest to go to learn more and kind of increase your own skills in using futures?
So what are good resources to learn more about futures? I don't want to sort of promote myself too much, but I have done a lot of future talks, so some of them can be useful. There is a blog series about the changes to Future in 2.12 that you might want to look into for reference. I have promised myself, but I won't make any promises for anyone else, to make the documentation even better. In general, though, I feel like there's really not that much to learn about futures themselves, but it's sort of incidental things around it. A really common case that I see is the creation of futures in for comprehensions and being surprised that they run not sequentially but triggered sequentially, because monad comprehensions are essentially sequential operations. So whenever you want to do start futures or start computations in parallel, you want to lift that outside of your for comprehension. All right. Anything else? Yes? Is there a plan to implement task in Scala? That's a really good question. So personally, I would love to have a task-like functionality. I think they complement each other very well. So task is essentially staging. It's a lifted representation of a workflow, and I think they're really complementary. So you could use a task to produce a value in a future that you could then expose to others, because task is not memoized. So everybody who wants the result of the task needs to evaluate the task. So I think they have really sort of complementary value, and I would love to see somebody propose something for that. I think that would be very interesting. Yes?
So what would be some of the trade-offs that you're actually looking at if you don't want to go like a primitive route or maybe bring more of an utopia?
To do what?
To do
Um,
for example, using features as opposed to using actions.
Yeah, and I think that's a good question. So that comes up quite a bit. So how do I know what to choose in terms of the abstraction to use for different things? And for me, futures are good because they are they have very sort of strict separation between the concerns of producing a value and consuming a value, which I find nice. They have very clean semantics. They interoperate with a lot of things because they are sort of monadic in nature. I think as long as you can have single sort of propagation, futures are good. But once you need to go into a streaming context, using something like FS2 or RxJava or Akka streams or something that is designed for multiple values that come in asynchronously. But these tend to really complement each other well. So you use something for some task, and then you produce a future for something else, and then you might go back and use that for something else. I see a lot of usage of future that I didn't anticipate. So like using future as a very common default thing to do. Like we do it in a future because it's async, and then we will be able to sort of scale it out using a thread pool and stuff like that. So nothing should be overused, and you really don't know what the right thing is until you have your your requirements sort of more specified. So it's hard to give like a blanket recommendation for stuff, but at least the abstractions we have today are very much more user friendly than, let's say, locks or semaphores and doing sort of stuff like that. So I feel like this is a good sort of end user API. All right, I'll be around, so don't be a stranger. Let me know what you like about futures and what you don't like, or your war stories. Thank you.